Ponderosa pine is the dominant tree throughout kind of Flagstaff, northern Arizona, this elevated area. And ponderosa pine trees are really, really cool. As they grow taller, they go through this kind of self-pruning process where all the low-lying branches will start to die and kind of fall away from the tree. But that helps the tree survive these periodic wildfires that the Southwest is prone to. So you can look up at the trees and you'll notice the branches that actually have needles on them are way up, elevated above the forest floor. Sometimes it's 20 feet, sometimes 30 feet, sometimes they're 40 feet up above you. So if a fire comes through, it's going to be burning these grasses and these shrubs down on the ground. And come over here and look at this trunk. You can see we've also got some black scorching right here on the trunk from where a fire came through in the past. But this trunk bark is so incredibly thick that it insulates the tree from that surrounding fire. So by having a high crown and a really thick trunk bark, as the fires burn along the forest floor, these trees are able to survive. And then as all this kind of plant life and debris on the floor of the forest gets burned up, it's very nutrient dense. So those nutrients cycle back into the soil and it helps to kind of fertilize the forest floor. So while wildfires are like the biggest natural disaster that you'll hear about in Arizona, the fire in the ponderosa pine forest is very important to the cycle of nutrients into the forest floor, into the soil. So that's why today you'll hear about things like prescribed burns and controlled burns, basically trying to use fire to our advantage. This is the needle from a ponderosa. You can see, so these 3 needles coming off of one little patch here, and they're pretty long, much longer than, say, your like pinyon pine or your Douglas fir trees. And what that does is as those branches kind of shed away, the needles are going to shed away as well. And these long needles kind of create a blanket on the forest floor. And that blanket blocks out the sunlight and prevents other plants from growing. So that's why ponderosas kind of dominate the landscape here. They're able to outcompete their other plants. But there is one other tree that you'll quite often find growing with the ponderosas, and that's our oak tree. This is what you call gamble oak. It's an oak kind of native out here to the Southwest, and it's also highly adapted to those fires. So if you look right here, you kind of see like a cluster of trees. That whole cluster is likely one tree. So underneath the ground, all those trunks are connected by one root system. And then as those fires burn along the forest floor, they burn up those trees. But those roots are insulated underneath the ground. So as the fire passes through, the gamble oak can just kind of shoot up these small, fast-growing trunks, and that's how it survives the wildfires out here in Arizona. Oak trees are known for the acorns they produce, and if you process them correctly, acorns are edible, and they're actually a pretty good food source. So for people that have been living in the Southwest kind of Flagstaff area for at least 5,000, probably 10,000 years or so, for a long time they were hunter-gatherers. So the deer and the elk and the rabbits and the squirrels, the game animals provided sustenance, but they were also gathering a lot of native plant material as a food source. So acorns were one of those foods that some of the tribes might take advantage of. And there is evidence in this area going back to, 10,000 years ago, the last ice age, the time when we talk about the Clovis people in North America. They have found Clovis points in and around the Rogers Lake area. So we know that going back to the last ice age, hunters and gatherers were also coming through this area using the resources from the water in Rogers Lake or from, maybe the acorns here or the animals in the forest. So while the Southwest is kind of, a dry desert climate that looks pretty tough to live in, if you know what you're doing and you have the knowledge and the history out here, people have survived here for thousands and thousands of years. Since we're in a pine forest, we're hanging out with a bunch of conifers and evergreens, not known for its fall foliage, But that's where the Gamble oak is so special. This is one of the only deciduous trees you'll find at this kind of elevation. And you can see we're out here in mid-October and the leaves are changing into a beautiful orange color, kind of going from their summer green into their fall oranges, you know, getting ready to drop these leaves for the winter. What I think is really cool about leaf changing though is that, you know, not a lot of people understand, like, why do the leaves change color? Why do they go from green to yellow or to red or orange? Like, why do we get that beautiful kind of mosaic of color that we see in the fall? Well, it kind of all has to do with the sun and how it's positioned relative to the earth. So the earth has its tilt, and that's why we go through seasons, you know, from fall to winter to spring to summer. So in the summertime, the northern hemisphere is kind of pointed more towards the sun. We're getting more sun, we're getting those longer days, warmer weather. But as the seasons change and the earth rotates and moves, now that sun is going to start going kind of lower and lower and lower into the southern sky. As the sun kind of moves its position in the sky, those wavelengths are not as efficient in the green spectrum, I guess you would say. And basically, the plants start using other chemicals besides chlorophyll to photosynthesize. So the chemical change is what changes the actual color of the leaf. So the leaves aren't changing color because, you know, they're dying. They're actually changing color because the sun is becoming less efficient as an energy source as the winter approaches. So they actually have to kind of change their chemical composition to take advantage of the wavelengths of sunlight that are available right now. If you ever see a pile like this, these are really common, especially in these Ponderosa pine forests. So the Ponderosa pine trees are reliant on fires to cycle nutrients back into the soil, and that kind of cycle of destruction, regeneration, growth, fire, all of that is kind of going on throughout the tree's life cycle. The problem is, in the 20th century, as we were moving further and further west, we stopped all those fires. We took a policy of fire suppression, and we didn't allow natural fires to burn through our forests. Well, without those fires burning through, the smaller trees, they continue to grow, but nutrients were not properly cycling back into the soil, so the older trees were kind of being outcompeted by these younger saplings, and it led to these heavily overgrown forests. And as the forest got thicker and thicker and thicker, all of that extra growth, that was just extra fuel for the fires to burn. So all of that fire suppression actually led to forests that were more prone to these bigger, catastrophic wildfires. Because those Ponderosa pines, with that high crown and lack of vegetation on the forest floor, they can survive the fires as long as they stay kind of low to the ground. But when you get all this extra growth into the forest, the fire can climb like a ladder up to the high crown of these pine trees. And then when the crowns ignite, the whole forest can be set ablaze. So those ladder fires are really, really bad. So today, to undo the work that was done in the 20th century of fire suppression and to prevent more and more ladder fires, the Forest Service has to do this. They have to do thinning, cleaning, and burning. So anytime you see a pile of wood out in the forest like this is typically what they would call a slash pile or a burn pile. So the Forest Service has come through, and you can see they actually physically cut down some of these trees. Cut them apart, collected the debris from the forest, and then they bring it all together like this and pile it up. Just when the time is right, you know, the winds are low, the moisture is high, that's when the Forest Service will send a crew out here and they'll be able to burn this pile. Whenever you're out in the forest, traveling through the Ponderosa pines, you see these piles, just know that that's work done by the Forest Service trying to make for a better, natural, more healthy ecosystem. We don't just have ponderosas here in Arizona. You can find them in Colorado, Utah, Wyoming, California, all throughout the West. They're a super common, super abundant tree. And as you're hiking through the Ponderosa pine forest, you'll notice most of the trees grow as one nice, long, straight central trunk. And that's why they were really good lumber trees. You know, they make really long, nice pieces of wood. But something that you should be looking out for are trees that instead of having one long, nice, straight trunk, they actually kind of split into two trunks. So right here, we've got a great example of the base of one ponderosa pine tree coming up, but then all of a sudden kind of veering off into two trunks. And then again up there, it kind of splits again. There are a few more trees like that. This one right here has a really nice kind of V look to it. So when you're looking at these trees, you notice that most of the trees are that kind of long, straight type of pine tree. So why are these ones split? What happened to these trees? And believe it or not, porcupines, those pincushion animals that you see in the forest, they are the reason that these trees are split. So porcupines are a forest creature. They eat a variety of different plant material from leaves to acorns. But one thing in particular that they love to eat is the inner bark of trees. So as these trees are young little saplings, kind of like what you see over here, the porcupines in the wintertime will come through and start to kind of split the tree apart to eat that inner bark. Now once they've eaten the bark, that tree is split and it starts to grow and it kind of veers away from one another. So after years and years of growth, all of a sudden, instead of one big long trunk, you've got these two splitting trunks that kind of break away from one another. Now these trees right here are pretty old ponderosa pines. These are a little less than 100 years old, I would say. Once the tree reaches about 100 years in age, they actually turn orange in color. So it's another cool thing about ponderosas. If you see an orange one, you know that's an old growth tree. So this tree, sometime less than 100 years ago, a porcupine came through, split it open, took a little snack on the inner bark, and then years and years of growth later, we've got these really cool kind of V-ing trees that you'll find ever so kind of rarely throughout the ponderosa pine forests. Just looking at this tree, this one's pretty easy to tell, you know, that's a young tree. It's not that big yet, you know, what do we got? Maybe 20, 30 feet high here, not super thick around. And we've got this kind of darker colored bark. And then if you look over here, all right, this is a little bit bigger tree, a little bit taller, but we still have that dark coloration. So that's how the tree grows as it's kind of maturing. And about 95 years into its life cycle, it finally reaches maturity. And you can see that kind of tree by looking at the color of the bark. So now over here, you can see a really massive, tall ponderosa pine, nice and thick around, and we've got that bright orange, almost kind of like cinnamon color to the bark. So this tree right here is a centennial tree. This tree has survived in this forest for over 100 years now. And you know, most people kind of date trees using things like tree ring dating, you know, cutting the tree open, counting the number of rings inside, getting an estimate of how many cycles of growth it's gone through. But it's really cool in these ponderosa pine forests how you don't have to have a cord, you don't have to have a cut of the tree. You can just kind of look at the outside of them and you won't know whether this tree is, you know, 100, 200, 300, could be about 500 years old. That's their average lifespan. Somewhere in that range is what you're going to see when you're looking for these kind of orange colored trunks. Another fun thing to do when you find these mature ponderosas is to kind of find the seams between the plates of bark. And as weird as it sounds, just stick your nose right in there and you'll get a slight scent of vanilla, almost like a bowl of vanilla ice cream. And it's just kind of the way the sap and the pitch in the tree smells as it's growing. So if the tree is not actively growing, they don't always smell like vanilla, but sometimes in like the spring and summer, you can get these really kind of rich scents off of the tree. And you just kind of look like a weirdo putting your nose up to a tree, but it smells really cool.